Hi there guys, and welcome to question 5. In part A we have to find an expression for y in terms of x for this bit of wire. Now it's important to read the text because there's information that they haven't put on the drawing. So a to e is x, so let's pop that on. I'm also told that this line here, a to b and e to d, are the same and they're both equal to y. Another bit of important information here is that the perimeter, the total length, is 2. Okay, so because I know the perimeter is 2, let's pop that down. And that means that x plus 2y plus this arc length of BCD, which is just half a circle. So I know that that is going to be pi d halved, okay, the circumference halved. And we know that's equal to 2, but we know what the diameter is as well, so let's pop that in. So it's x plus 2y plus the diameter is x, so it's pi x over 2, which is to 2. Okay, so we can do this now. So we're just trying to find an expression for y in terms of x. So the y is positive, let's leave it there. Let's get rid of everything else. So we're going to have 2 minus the x from both sides, minus this term from both sides, and there we have it. But this is 2y, so we've got to find y. So y is equal to 1 minus half x. Be careful here, we're dividing by 2, that's the same as timesing by a half. There we go. So that's my expression for y. It's not really an expression, it's an equation, but yeah, I'll let them have it. Okay, so let's do part B. We'll change colour for part B. So we have to prove that R, and what they mean here is this is the area, okay, the area enclosed. So with area, compound shapes, we normally split them up. So it's a nice vertical line-ish. So you get what I mean. But this whole area here is R, which means R is equal to xy, this rectangular part, plus the area of the semicircle, so it's pi r squared halved. Okay, so I'll deal with this first bit, the second bit. So the radius is this length here, which is half x. And that's actually being squared, so what we've got there is x over 2 times by x over 2, which is x squared over 4. But that is being multiplied by pi, so I've got pi x squared over 4, and that's being divided by 2, which is the same as times and by a half. So what I actually have there is pi x squared over 8. Now this over 8 is making me happy because that's the over 8 in this question. So it's looking good. Now I also know what y is, I've just written it there. So let's pop that in as well. So x brackets 1 minus x over 2 minus pi x over 4 plus this pi x squared over 8. Okay, here's a bracket. The only thing we can do now is expand this because this isn't exactly the same. So let's keep going. So we get x minus x squared over 2. This is looking good. Minus pi x squared over 4 and plus this pi x squared over 8. Okay, because this is factorized for over 8, that means all of these, if I expanded them, are over 8. So let's do that. Let's make them all, let's put them at r equals there. Let's make them all over 8. So we're going to have 8x over 8 minus 4x squared over 8 minus 2 pi x squared over 8. We don't have to change this one. Okay, but now what I can see is I can collect these two last terms. And just give me minus 1 pi. So let's write that. Let's just drop it down a bit. So r is going to be 8x over 8 minus 4x squared over 8 minus this 1 pi x squared over 8. Okay, so one more thing to do. Let's see if this factorizes correctly. So let's take this x over 8 outside. I've got to times by 8. That's the first bit. I've got to now times by 4x to get this numerator. Okay, again that's right. And pi x to get, and you'll see that that's exactly what they wanted in the question. So we've proved B. Okay, so in C, we're told that x can vary using calculus. So we're going to have to think about our differentiation to work out the maximum value of r. Okay, so what I'm gonna do first is just make a little sketch of this. So I'm going to try and sketch it. This is not going to be accurate, but it's going to serve a purpose in understanding why we're doing this. So let's say the area is modeled by, say, this graph here, and that could be, you know, because this formula for r is pretty nasty. It's going to be a pretty nasty graph. But you can appreciate that when x is here, when we have this value of x, we get the highest point for the area, and that's actually a stationary point. So we know here that the gradient, in this case, it would be, I called it A, but it's actually R in the question. So this is going to be dr by dx is equal to 0. Okay, the gradient is going to be equal to 0. So this is what we do to try and maximize something. Right, so let's write out R. We're going to have to differentiate it. Now, it's in my interest to make R as simple as possible. So I don't want it factorized. Let's take this one, but what I'm going to do is I'm going to simplify that. Let's get 1 and 2. That's 1 and 1. So we'll take this one. So we've got x minus x squared over 2 minus pi x squared over 8. Okay, so let's find dr by dx. So it's going to be 1. So a half times 2 is just 1, so it's going to be minus an x. Here we have an eighth times 2, which is going to be a quarter. So I'm going to write it like this. And there we have it. Okay, so let's put this equal to 0. So 0 is equal to 1 minus an x minus pi x over 4. So what we want to find x. Okay, this is what we're trying to do. Find this value here. So the x terms are all negative. So I don't like that. Let's make them all positive. So we're going to have add both of these terms to both sides. So we're going to have x plus a pi x over 4 is equal to 1. It's just so much nicer now to deal with. Let's times everything by 4. So if we have 4x plus pi x is equal to 4. And now we can factorize for x, allowing us to solve it. So x is going to be 4 plus pi equals 4, and therefore x is 4 over 4 plus pi. Okay, so that's that bit done. That's the value of x, but now we've got to find the maximum value of r using this value of x. So this is when r will be at its maximum. Okay, at this point, you may want to store that answer, and it's not going to be a nice answer, but you might want to store that in your calculator. Yeah, store it as a letter, and just use that letter and type in this equation for r. Okay, but we've got it written here. So what I'm going to do basically is take this value and write it in all of these places. So it's going to get pretty messy. So r is going to be equal to 4 over 4 plus pi over 8. We'll tidy that up in a minute. 8 minus 4 lots of 4 over 4 plus pi minus pi lots of the same thing, so 4 over 4 plus pi. Okay, so if you think about this, we've got 4 over 4 plus pi, and dividing by 8 is the same as timesing by 1/8. So we're actually going to get here, we're going to get 4 over 32 plus 8 pi. And while I'm here, I recognise they're all in the 4 times table. So that's going to be 8 plus 2 pi. So I'm just going to now skip this because it's pointless writing it in twice. Actually, no, I'm not, because I reckon I'm going to need a few tidy ups to finish this one. So it's going to be 8 minus 16 over 4 plus pi minus 4 pi over 4 plus pi. Okay. These have the same denominator, so this is what I'm tempted to do, is make that the same denominator. So if I times it by, because at the moment it's a 1, okay, so let's times it by 4 plus pi. So we're going to have 8 lots of 4 plus pi minus 16 minus 4 pi. And that's all going to be over 4 plus pi. Now, looking at this also, I noticed one more thing. You might not see this straight away, but it should make sense to you. But that's actually 2 lots of that. So I'm going to write that. So that's 2 lots of 4 plus pi. Now, let's take our time and let's expand this. So we've got 32 take away 16. That's just 16. We've got 8 pi minus 4 pi. So that's, so here's the 8 pi. 8 pi minus 4 pi, that's a positive 4 pi. And we've got 4 plus pi there. Okay, so it's looking relatively nice here, but it's not, is it? And this means times, so let's go ahead and times these together. So we've got 16 plus 4 pi. Now, because they're the same, I'm gonna leave it like this. I'm just gonna put them in like this. Now you'll see here what I can actually do is I can factorize this. Yeah, if I factorize this for 4, I get 4 plus pi. And I'm sure you can guess what I'm about to do now. But I can definitely simplify these. Okay, so I can cancel those out. That equals 1. And these are both in the 2s, so I actually get, as my final answer, 2 over 4 plus pi. You have a calculator, guys, so just type it in. But that's how you can do it without a calculator. Let's say it breaks and there's no spares.